All right, we are doing CPM 8.2.2 exponent rules. All right, great. Make sure that you have your rules from the other day out. I passed them out this week, and we may go through some of these. I know on 8.2.3, we go through a lot of the rules. So let's start with 5-59. And these are called product rules. And I think we're going to have some quotient rules in here shortly. Okay. So this is called the product rule. Remember, the product rule is when you're multiplying two exponents with the same base, you're basically adding them. Okay, great. So we've got 859A is 10 squared times x cubed times 10 times y. Okay, so what bases are alike? Well, this base and this base are alike. So what is this going to equal? The factored form is going to be 10 times 10 times 10 times x times x times x times y. So what is this going to be simplified? It's going to be 10 to the third power, x to the third power, and then y. So this is your answer. Okay? Great. Let's take a look at B. B is 20 to the third power times 20 to the 8th power. Okay? Remember, these two things have the same basis, so we add them, but they're multiplying. So what does this become? What is 3 plus 8? Yeah, Tam. Perfect. So you have 20 to the 11th power. Questions? Okay. Let's take a look at C. So we have x squared, y squared, z squared, oh my goodness, times x to the third and z to the fifth. Okay, great. So what are like bases? Well, this is a like base and this is a like base. And this is a like base and this is a like base. So what do I come up with? Nope. Cairo. Or Kane. Sorry. Kane. What are we going to get here? Perfect. Absolutely correct. Is there anybody that doesn't understand this one? Okay. Now, on 8-60, we are looking at 5 times 5 times 1, 2, times 5 times 5 times 5 times 5 times x times x times x. They want to know, is she right with her 25x squared, 625x cubed? That's her answer. They're wanting to know if this is right. Is this right? No, Sebastian, why isn't it right? Take your time. Oh no. When you multiply 5 times 5 times 5, it becomes 625. But if you look, they're adding everything. And this isn't adding. Everything that we're doing is multiplication. Everything we're doing. So if you take a look and just add up your 5s, 1, 2, 3, 4, 5, 6, you have 5 to the 6. How many x's do you have? 1, 2, 3, 4, 5. So you have x to the 5, to the 5th. If we were going to multiply this out, which we could do, we do this. We go 5, special button, 6 equals 15,625. X to the 5. We can't deal with the x at all because we have no idea what it is. How do we feel about that? Okay, great. All right, let's take a look at 8.2.2 right here. And we're just going to take a look at, now, we have moved into a different rule. We are now starting with the power rule, which if you remember, it shows that if you have the same base and an exponent here and an exponent here, they are going to multiply. The exponents, oops, you can't see that, multiply. Okay, so we're just going to take a look at this, right? And we have original formula. Okay, we've got factor form. And then we've got simplified exponent. Great. So here's our original. We have 5 squared to the 5th power. Notice the parentheses are there. And it shows us, we multiply it out like this, 5 times 5 times 5 times 5 times 5 times 5 times 5. Oops. And then one more time. And it actually equals, remember, these two multiply. So this becomes 5/10. Okay? 5/10. The next one, you have 2 squared to the 4th power, right? And it would go 2 times 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 2. Or what could you do? 1, 2, 3, 4, 5, 6, 7, 8. You're going to have 2 to the 8th power. Okay? Remember, this is once again power rule. You have the parentheses. One power is on the inside and one is on the outside. You have 3 to the 7th power times 2. What are you going to get? Even without factoring it, what are we going to do here? Silas, what is 3 or 7 times 2? What? Perfect. So this is going to be 14, right? Because we're going to go 3 times 7, 3. And it's going to equal 14 threes. What about this one? X to the third. Writer, what is this one without factoring it out? Yep. Thank you, writer. And then the last one we have is going to be x to the third times y squared times 2. Remember, you've got all three. This times this, and then this times this. What do you get on the other side? What is 2 times 3? 6. What is 2 times 2? 4. Okay. Questions? No questions? Great. Okay. They're like visualize. Let's look at this one. This is the same thing. We're going to do 20 to the third power times 8. What are you going to get? Angelo, what is this going to become? What did you just say? You don't know? What is 3 times 8? Mike, what have you got, G? 24? You are absolutely correct. All right. Here's our next question. 8-63. You have 2x to the 3, or you have 2x cubed. Is this going to be the same? Are these two things the same? No? Well, take a look at what this does. This is just going to be 2x squared, or cubed. This is going to be 2x times 2, well, 2x times 2x times 2x. Are they the same? No, they are not the same because this is being multiplied 3 times, right? Good. So they are not equivalent. Okay. Now, okay, great. 8 dash, actually, I'm just going to jump to 8-65. And that's the last we're going to do, 8-65. Great. And I'm going to show you this. This is actually going to jump right into the quotient rule right here. And the quotient rule basically states that when you have the same base with exponents, they're subtracting. Okay? So I'm going to write they actually subtract. So, and I'll show you what that means right now. So you have A you have 2/4 over 2 halves, or 2 squared. It really looks like this. 2 times 2 times 2 times 2 over 2 times 2. Now, when these guys are below a fraction line, it makes them negative. So you're actually just like subtracting them. So this goes away and this goes away and this goes away and this goes away, and what you're left over is 2 squared. Okay? Let's take a look at B. You've got 3/4. Is that right? 3/4, yeah, and 3/5. Which also equals 3 times 3 times 3 times 3, or 3 times 3 times 3 times 3 times 3. These cancel each other out, and all you're left with is 1/3. Okay, let's do C. Y7 over Y4, or Y times Y times Y times Y times Y times Y. 1, 2, 3, 4, 5, 6, 7. Y times Y times Y times Y. All right. So we cross cancel, right? We got done, 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 done. And how many do we have left over? We have 3 left over that are above the line, so it's Y third. All right. Ready for one last one? Hold on. Oh, wait. My bad. It's all right. All right. The last one is a little complicated, but it's not crazy complicated, right? So we've got, let's get this one over. We've got D. We've got x to the third, y to the second, over x, y to the second. And watch, I'm just going to do this. X times x times x times y, y, over x times y times y. All right, let's start cross-canceling these out. What have you got left over? Mr. Homan. Liz, at x squared. And that's it. Questions? Questions about this at all?